What's going on, smart people? Initially, I wanted today's video to be another funny video, but time is not on my side today, so I need today's video to be more so about the homework that I am struggling to get done on time that is due tomorrow. I've mentioned it before, I'm not a procrastinator. I get started on my work right away, and I have my math methods and quantum mechanics homework due tomorrow, and I'm still not even close to done. And so far, it doesn't even seem like the homework is that hard necessarily. It is just tedious and long, and this one problem took me 4 pages. So I figured for today's video I'd go over a brief description of what the homework is on without getting to the actual problems themselves. For math methods and quantum mechanics, none of the questions are straight out of the textbook, so I can't really just say this is the exact problem. It's just not fair or maybe legal in a university context to do that kind of thing. So let me take some time to break down what the material is going over. Now, these homework assignments were assigned about a week and a half ago, so that's kind of the deadline of how far the class had gone, which means for quantum mechanics we were still really just reviewing. So this homework is all on linear algebra. Now, I can actually give an example without going over the specific problem where it gives you the states and stuff, but for one of the problems it gives you 2 operators acting on 3 different states, and from that you're supposed to construct the matrix representation of those operators, determine if they're Hermitian, find their eigenvalues, eigenvectors, and then see if they commute. So it was a lot of matrix algebra. Like I said, it wasn't necessarily difficult. It's just when you're dealing with a bunch of 3x3 matrices, it's like, oh my god. That's why things become 4 pages long. And that problem wasn't meant to be like inherently difficult. What it is it's supposed to make sure everyone remembers consequences of linear algebra in a physics context. Like, it's making sure everyone remembers how to find matrix elements. If we found out that the operator is Hermitian and then we calculate the eigenvalues and eigenvectors, those eigenvalues better be real. And so things like that. Or if they commute, then you know quantum mechanically that means that you could make simultaneous measurements on both of their eigenvalues at the same time. So though the linear algebra itself isn't hard, it's making sure you remember what it means when you apply it to physics. And now I've just got one more quantum homework problem to get knocked out, which is actually giving me a little bit of trouble because my professor has 2 states written in terms of other vectors, and those vectors are orthogonal but not orthonormal. But we don't know what those vectors are, so it's not just like normalize them real quick, which means that when we take the inner product between them, normally the dot product between things that are orthonormal is either 1 or 0. If I equals j, it's 1. If I doesn't equal j, it's 0. But since they're not orthonormal, I don't know if they want me to write it in terms of the metric or if there's just something that I'm missing. So that one's giving me trouble, so I'm moving on to my math methods homework, which it's pretty straightforward. It's just a lot of Fourier analysis, so writing Fourier expansions of functions, proving some convolution theorems, and doing some integrals of delta functions. So it's pretty straightforward, unless there's something subtle that's lurking in there that I can't see at first glance. This should be much more straightforward than the quantum homework. But I still do need to finish this up, so I'm probably going to call the video here. It's almost 6 o'clock. Still got to go grocery shopping. Let me know in the comment section if you'd like to see me go over some of these more really just mathematical problems in the future, whether that be the linear algebra side of quantum or the Fourier analysis side of math methods right now. So let me know in the comments, and I'll see you guys there.